What else is needed in the US? And yeah, to unlock that, to unlock that new economy, like the new nuclear economy that's like hasn't existed for the past 60 years. So what's needed? What's the rest of the ingredients?
So I think aside from financing, so there's financing for developing the projects, but there's also on the other side of the financing, there's the demand, right? So you have to have customers that are willing to pay a premium for baseload power.
What prompts a customer today to pay a premium for baseload power?
Truly what prompts them is when they don't have other options.
When you look at the market of your competition, the entire market for nuclear could be reactor designers, could be IPPs, independent power producers. How do you segment it? The US and internationally, whatever you think it's best for us to understand. But I really want to get from you the perspective of how is the market split?
So I think the easiest way to first think about it would be, I guess you could either go first by size or by technology.
Hey everyone, and welcome to BitBuilders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology, and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hello, hi Michelle. Welcome on BitBuilders.
Hi, thanks so much for having me.
Do you wanna kick it off by introducing yourself?
Sure. So I'm Michelle Brechtelsbauer. I'm Vice President of Strategy at Last Energy. At Last Energy, we are a modular nuclear power plant developer. So we build very small nuclear power plants and sell electricity and heat to help industrial off-takers decarbonize their operations.
There's a ton to unpack over there. I guess we can start from any of the words that you put in line. But I want to start from the first one, which is just your name, and kind of want to see what you did in your background that brought you to helping designing and selling and commercializing small modular reactors. Because I think it's super interesting.
Yeah,
I think more and more people in our generation are actually going to do this as a job. So, how did you get here? What's your background?
It's a great question. So you can't tell from my accent. I was American, born and raised in the South in Alabama. I studied chemical engineering in undergrad, and did a lot of my early work in, carbon capture, and kind of started looking at the energy transition through the engineering lens. When I was in grad school, I caught the policy bug, as they say. I took a few policy classes, energy policy classes, and just absolutely found kind of my people. I love kind of being in between the technical and the folks who are really thinking about it kind of from the macro scale in terms of technology impact and deployment. And so I moved away from engineering and actually moved to Washington, D.C., which is where I currently am, to work for the Office of Science and Technology Policy, which is an office within the Executive Office of the President at the White House, that supports the president from the high level, thinking about how their priorities can be implemented across all the agencies working on a specific science or tech issue, be it climate or Earth observations or nuclear. I worked in DC kind of in that space for about the first 5 years of my career. And then I got pulled into the startup world. Last Energy's founder, Brett Kugelmass, and I met about 6 years ago. And he asked me to join his company, which was just him at the time. And so I became the first employee of Last Energy. Then we were working under kind of in stealth mode as the Energy Impact Center, just trying to understand the space, trying to understand, the impact that nuclear could have, what the true problems were with deploying this technology, from a physics and science perspective. Everything works on paper, but for some reason we saw this, big stagnation in the industry. So we spent the first few years just trying to understand that. And doing a lot of strategic thinking about how we can make a difference in this sector, and then formally launched Last Energy to really tackle the solutions that we started to define. And I guess the next 4 years we'll get into what that solution actually is. But yeah, so I've been with the company for a little over 5 years, and it's been a really incredible journey for me personally to go from, the science and engineering background to a policy background, and now to really be in like the development and solutions delivery space. It's really huge for me as someone who cares a lot about climate change, energy poverty, energy access, and really just creating a better world for everyone.
I love it. And for background for the audience, I actually met Michelle in an event where I basically tackled her and said, "Hey, let's chat because I know what you guys are doing and I love it." And I was telling, Michelle just before hitting record, that I actually listened for the first time to Brett talking on Titans of Nuclear. Yeah. Was the podcast that Energy Impact Center was producing before becoming Last Energy, before you guys got out of stealth. That is a great podcast, by the way. Just, everyone should go and listen to it because it's the deepest, the broadest and deepest podcast on nuclear, interviewing all sorts of experts, of all sorts of sides of the industry. So that is just the best. And I love what your what your motivations are to get to Last Energy. And your career seems like it's a given lift to that idea, as if it was destiny. You were gonna join a one person company developing nuclear reactors. Let's start from the basics. Why nuclear reactors? Why is this something that we should care about today? And they're an old thing, aren't they? What are we doing here?
Yeah. So why nuclear, and why did we as a business, and why did Brett, our founder, focus on nuclear? So maybe I could talk a little bit about his background because it's really foundational to our company's story. So Brett is, I guess, a second time founder. This is his second company. His first business was a drone business that he started after his work at Stanford. And he sold that business to one of his clients, actually. And then, as many exited founders do, decided to take a year off, just kind of enjoy the less stress life. And he, planned to really, just gallivant around the world. And he barely made it even just a few months because, Brett is similar to me, really motivated by tackling hard problems. He's also an engineer, mechanical engineer. And he started speaking with his professors from Stanford around climate change, just trying to understand, what is the solution space here? And, all these conversations about renewables and carbon capture and batteries and all these types of technologies. And he started noticing this trend that at the end of the conversations, most of them ended with some sort of comment like, yeah, but if only nuclear, then that would be the true unlock, right? It's like people don't want to say it until they've kind of exhausted all the other technology options, because, you have to remember this was 7 years ago. Nuclear was not popular to talk about. It's only very recently that we kind of feel like we can talk a lot more openly about it. And so he started really digging into that. There's clearly something there. So kind of what I was alluding to earlier, right? Just from a first principles kind of perspective, you just look at the technology, the energy density of nuclear fuel is absolutely enormous. And it's so much more efficient than any of these other clean technology solutions we're looking at. But in practice, in reality, as I said, there's been this massive stall. And so, it kind of became this realization for Brett that it wasn't actually a technology problem, but it was more on a delivery and business model problem. And that's something that is easy to solve. It should be easy to solve, right? We don't need to reinvent this old technology, as you said. We just need to repackage it in a way that it can be delivered, and solve the economic challenges and the time challenges. And that's actually why it makes sense for us to be talking about nuclear, I think, and our approach to nuclear on your construction-focused podcast, because it all comes down to, can you package it in a way that it can be built quickly and efficiently and not cost, billions of dollars? And so that's why we focused on nuclear, because we saw that the solution would not be, too difficult of a technical problem, but it actually would be more a kind of a holistic approach to designing, thinking from a kind of full systems integration perspective. How do we just deliver this technology in a way that's more standard, productized, and ultimately can be scalable to address, the big issues here. Another reason why nuclear, right? When you think about climate and the energy transition and the technologies we have available, renewables are great, right? But the thing is, they don't produce heat. And so if we're really going to replace fossil fuels, we're going to have clean sources of heat, and we're also going to have clean sources of baseload power. So of course, battery technology does come into play there, but if we can have a technology that produces 24/7, clean electrons, then that's going to be really the key unlock. And we need to be able to do that at a scale that can be, at the most hyper local, but also at the grid scale. And so that's something that we've also thought about in designing our product to be small enough that it can be mass produced and fit any of those size applications.
And to kind of complement and like give little pieces of little notions that might be needed to fully contextualize for the audience. When we talk about clean energy sources, you can have the most common clean energy sources are solar and wind, and these are by nature, by the physics that is the prime mover of those energies. It's intermittent energy, and we're talking about baseload energy when we have fully sustained nuclear reaction that it's heating up the water, channeling the steam, moving out of a turbine, moving a generator, and creating electrons to have flow in a grid or directly to the load, which, by the way, is the current interest of Microsoft and Amazon that we've seen. And, I'm sure you guys have had a really big I told you moment when that stuff came out. But this is the fundamental difference. So the fundamental difference is that we will not solve, it's really difficult to solve without extremely big leaps in storage. With intermittent energy, the current supplant of energy sources that are fossil fuels without having baseload power that is also clean.
Yeah,
so
yeah.
That's
there
the
are
key,
key
right?
baseload sources, right? Geothermal, hydro, but the issues there are they're location dependent. Actually, solar and wind are also highly location dependent, right? Not everywhere has, strong enough winds or great enough sun to make those good options. So when the cool unlocks that nuclear brings is that it can literally go anywhere. And from our perspective, it's just an infrastructure challenge, right? It's even easier to put in place than the fossil sources it's replacing because its fuel, right? It's energy input, isn't like, with coal, kind of constantly have to have a rail line bringing in, more coal or natural gas. You have to have pipes going to your facility. It's a kind of like a standalone unit, right? Yes, there has to be a refueling cycle every few years. But that's just a truck coming in and out. And so that's actually really, it's a big advantage, for nations that are looking at, well, if I don't have all of these other geographic, dependent resources, I can have nuclear, and nuclear will give me electricity. It'll give me heat. It'll give me baseload power that I can operate my grid, my factories off of. And it's clean.
Yeah. And the question here becomes, and I don't want to open the Pandora box completely here, but I do want to spend some time on what, Titans of Nuclear, Brett, have been trying to advocate for years.
Yeah.
is actually try to answer the question first, why hasn't this taken off? Why are we, because this is the case, right? We're not using incredibly novel reactor designs. We're using actually fairly old for the, like old is in our usual pace to think about technology. This would be old. If it's 10 years old, it's already old. We're not using incredibly old reactor design, new reactor designs yet. This hasn't taken off until today, where you have big load demand like data centers that are coming online, or also arc furnaces for steel making that are coming online, where basically you have an incredible amount of energy that needs to be produced. And so now it becomes all an economic challenge, and the entire regulation and feeling challenges start to become less important because the economic challenge becomes the dwarf. So why hasn't this taken off before? What is your view on what is wrong in the permitting process, for example, in the United States? Where has it been better? And what's your response to that as a business?
Yeah. So I guess to answer the question around kind of the history really briefly, as you alluded to, it really has always come down to economics. There was a nuclear build heyday, right? I mean, right now we have, I don't want to get the number wrong, but let's call it, I think 98 operating reactors. We had at one point, over 100 operating nuclear reactors in the United States. There's roughly 500 that have been built all around the world. When the first wave of these plants were being built in the U.S., it was actually under a different regulatory framework and a different regulatory agency, actually, kind of the precursor to the United States Nuclear Regulatory Commission, or the NRC. And it was just this time of, I think that the slogan back then was, it's going to be too cheap to meter, which never actually was realized. But so there was this big building heyday of nuclear power plants. What kind of started to happen in the 70s, 80s, is these construction projects really started getting bigger and bigger and bigger. Plants started getting more and more complex. And that started to increase the costs, obviously, of these plants, and really slowed down the building of them, right? Because they were starting to enter into, what used to take, 3 to 5 years to build one of these projects, when they were, roughly between 400 and 600 megawatts. Now these plants are being around, a gigawatt in terms of electrical output, which obviously means it's a lot bigger and a lot more complex. And they just became, just like you would see, a really complex bridge that's being built, ballooning costs. That's what started happening in the nuclear industry in the US and all around the world. And that's really what it kind of started the slowdown, is because the plants became too expensive really to build in the first place. We just saw the latest nuclear power plant that came online in the United States, Vogtle 1 and 2, was, I want to say, upwards of $30 billion paid for by the taxpayer. It took 10 plus years to build. Same story in the United Kingdom with Hinkley Point C, same story all over Europe. And, really what we're seeing today is we've kind of lost the momentum of the boom in the 50s and 60s in terms of building. We've lost the supply chains, we've lost the workforce, the expertise, and we still have these mega construction projects. And so that's one of the things that we've been trying to tackle as a business, right? How do you actually tackle first the delivery challenges of cost and schedule, right? And so for us, that meant instead of building, gigawatt scale plants, or even 500 megawatts or 300 megawatts, go as small as you can to really fix those issues first. Embrace new techniques around construction that have been pioneered by the oil and gas sector, like modular construction, right? Where you can control many more variables, and you can start to standardize and gain efficiency by building first in a factory and then deploying on the field. So that's the approach that we've taken. So when I called it earlier a micro modular nuclear power plant, what I literally mean is that micro is 20 megawatts. So as opposed to that gigawatt scale, 20 megawatts. Modular is that it's made out of, independent modules that fit on the back of a flatbed truck, right? There's about 40 of them in our plant. They're produced in the factory setting. and then they're shipped to the site where the plant will be built, and they're snapped together very much like a Lego kit, right? Which helps to minimize on-site field construction and specialty labor risk that typically helps to balloon that overall cost of delivery. And then nuclear power plant. Why did I call it a nuclear power plant as opposed to a reactor? But you'll often hear people talk about in the nuclear space, just call it a reactor. That's because our business model is actually very different as well. We're designing a full nuclear power plant. We are building them, owning and operating them as, standalone units, assets. And then what we sell are the electrons and the heat that come out, right? So we set ourselves up under a PPA model, also kind of pioneered by the renewables industry here in the US, power purchase agreement, where our customers don't want to operate these assets. They just want the electricity, right? So we set up an agreement, a contract called a PPA to provide that.
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
So that's kind of the approach that we've taken. Another thing on the reactor bit is we're not an OEM, right? A lot of the nuclear companies of the past would and even some of the ones that are, the advanced reactor technologies that you'll see out in the market today are really only designing the reactor, and they aren't thinking about the rest of the balance of plant. The reactor isn't where we think the innovation needs to be. You have to think about it from a full systems perspective, because the overall cost delivery is the challenge we're trying to solve. So we set ourselves a design target early on that our power plant had to cost less than $100 million capital expenditure to deliver. And that we've stuck to that. And that's really critical, we think, because it also helps to unlock a whole new financing strategy, right? So $100 million is kind of chump change to private infrastructure investors, right? And so that's unlocking a whole new capital source for this industry that hasn't been able to access private capital before. As I mentioned with Vogtle, right? That was taxpayer funded. All of these large plants that cost tens of billions of dollars have to have government subsidy. And that's just also not sustainable or scalable, right? If you're really thinking about kind of providing this electricity everywhere, if a government doesn't have billions of dollars, then it's not going to be an option either. It doesn't matter if you kind of, as I went through earlier, when you're going through the energy sources, if you can't get any of those other resources because of geographic constraints, you don't have billions of dollars, you also can't get nuclear. So we have to fix that too.
What's missing too, this is a great point on financing, especially because what you do is basically you're unlocking for this asset, which has never benefited from that. You're unlocking access to private capital. And we're actually seeing this really, really closely. I mean, we've seen a bunch of VC-backed startups, a few PE-backed businesses, roll-ups of, reactor makers, roll-up of the business, the kind of like bigger companies that sell off their reactor business to other entities, and these other entities are trying to verticalize. So there's a lot of activity today. I think many have come to the realization that if you start slow, start small, nuclear deployment in the next decade is actually going to be a thing, maybe the thing. And so you are unlocking the access for these assets to a financing market that didn't exist before. What else is needed in the US?
Mm-hmm.
And to unlock that, to unlock that new economy, like the new nuclear economy that's like, hasn't existed for the past 60 years. So what's needed? What's the rest of the ingredients?
Yeah.
And do we have a different place in the world that this is already kind of a thing? It's already possible. And shouldn't we be there, to start?
Yeah. So I think aside from financing, so there's financing for developing the projects, but there's also on the other side of the financing, there's the demand, right? So you have to have customers that are willing to pay a premium for baseload power when there are alternatives that are going to be cheaper. I think one of the reasons that Last Energy has started our go-to-market strategy focused on Europe has been that exact reason, right? Where there are strong, laws around decarbonization of grids. There are geopolitical reasons for countries to move off of, natural gas supplied from Russia, for example. And they're already phasing out many of their fossil assets. So that means that there aren't the same options for cheap natural gas as we have here in the US. So that's one big factor. But when I say you have to have customers are willing to pay that premium, right, they have to value baseload power. For us, we don't sell to like the grid operator. We actually sign PPAs directly with an industrial customer, so an energy user. So it's kind of behind the meter, off the grid. So for us, that's like, literally anyone who has a manufacturing process and needs to operate kind of continuously is a great customer. So they need 24/7 power, and sometimes they also have a process steam requirement. And then data centers are as you mentioned earlier, kind of half of our market, and for both cloud applications and increasingly for AI applications. And with those customers, they need 24/7 baseload power, but it needs to be time matched. And that's a really critical thing that nuclear can provide. And it also has to have that reliability factor. They call it triple nines of reliability in the data center industry. So it's not just baseload, but for sure it's going to be on all the time. And so that's really critical. So that demand piece. And then the other part is an enabling regulatory environment, right? This is, at the end of the day, a project that we're developing, right? And so you have to have, obviously, nuclear is treated differently for good reason, for proliferation risk, in terms of how it's licensed in individual countries. So you have to go through the nuclear licensing process. In the United States, that's through the NRC. In the UK, where we have our first projects recently announced, that's the Office for Nuclear Regulation, ONR. And the regulator there has to be, able to look at technologies and grade them on kind of their actual proportional risk that they're providing. And that's a big difference that we've seen between the European regulators that we work with and the US NRC. And then, of course, planning and all the other fun stuff that comes along with any other energy or construction process, environmental permits, et cetera. Those processes need to be streamlined and enabling for these projects to be developed and to be developed in a cost-effective manner. So all those things have to come together, right? You have to have something that the developer can get financing for. There is customer demand. And then there is an enabling regulatory environment for the projects to actually be realized.
What prompts a customer today to pay a premium for baseload power?
Yeah, I say, well, truly what prompts them is when they don't have other options. So it's rarely that someone's like, I want my power to come from, nuclear or even renewables or whatever, right? It's not like customers really think about it like that. They just want to know that they have power so that they can get on with their own business. One of the things we've seen in the UK that's really interesting, that's probably less of a factor here in the US, is there's not a lot of land in Europe. There's just less land, so solar and these larger land requirements are actually not great options there. Nuclear's footprint. One of our power plants is about a third of a standard soccer pitch or football pitch. So very small in terms of its footprint. So we can literally site these right next to a facility. So there's the land requirement, the baseload requirement. As I said, if you can't get fossil fuels because those are being phased out, then there's not really battery storage, and that kind of just leaves you with nuclear. But really, those who are truly willing to pay that premium need it because of, as I said, that time matched, 24/7 reliability of power supply. So data centers, manufacturing processes, where, their business requires energy to operate, and they couldn't function without that. And so, it's really just, I think right now we're in a really interesting point in the demand cycle from industrial users given the energy transition.
This is really interesting because I want to try and understand. This is an opportunity that everybody's seeing, right? Everybody's seeing this uptick in demand, less willingness to, for example, wait a lot and build. Just you need to have scale and you need to have it fast. We're also seeing is the owner operators of those facilities that will need that baseload power are those types of guys that don't really like to wait. So if we're talking about data centers, we've seen it a lot with construction, and what you see with construction, data centers need to be fast to be built. If you actually compare the dollar value to the schedule of these facilities, you'll see an extreme speed and efficiency that they are forecasting and they're trying to enforce in the general contractors, and the subcontractors are making this happen. So everybody's seeing this opportunity. When you look at the market of your competition, if you're the entire market for nuclear, it could be reactor designers, it could be IPPs, independent power producers. How do you segment it? The US and internationally, whatever you think it's best for us to understand. But I really want to get from you with the perspective of how is the market split?
Yeah, so I think the easiest way to first think about it would be, I guess you could either go first by size or by technology. So I think it's maybe easier to first think by size because that's where you think about different applications, right? And I think that's how people typically think about this. So as I mentioned earlier, like the large plants, right, the 500 megawatts to a gigawatt, those are grid application only. And in every case, those are also going to be existing technology, pressurized water reactor technology. So those are still being built around the world, but those are going to be government projects. So then you kind of get into like the new types of nuclear designs that are coming online. And I'll say these are 500 megawatts and below because there are some big ones out there that are calling themselves small, but they're still grid applications. And so amongst those, then that's when you want to start thinking about the different types of technology. And the technology difference primarily starts with the fuel, right? So I've mentioned pressurized water reactors a few times. That's what Last Energy uses. But what it means is we use the standard fuel that you'd see in any AP1000 operating, near you. It's 17 by 17, 4.95% enriched, 12-foot tall fuel bundles produced by folks like Westinghouse or Framatome, for example. And those supply chains exist. They're the ones who supply all 300 nuclear or PWRs around the world. So that's kind of that's one type of fuel. And then the other type of fuel that's brand new, doesn't have a supply chain yet, is called HALEU, high assay low enriched uranium. And that's a higher enrichment than the standard fuel I just described. And it comes in a few fuel form factors. You might hear the word TRISO, which is essentially like a big ball. And so these new fuel types are some of the other reactors, vendors, designers are using these new fuel types. And then you have some other types of advanced reactors like molten salt, different types of coolants, molten salt, and others. And so you have this gradation by reactor fuel type and coolant type. Where we kind of fit in is using the same tech as the big guys, but just making it smaller. So it's from like a risk perspective, we have an existing supply chain, and we're just kind of changing all the variables that actually make sense to change from a delivery and construction perspective, as opposed to reinventing the reactor core. I think another key difference around those who are using those new fuel types is it does require major changes to the way that, the physics and the chemistries work in the reactor. So they're having to completely reinvent the reactor. And so that, of course, introduces delays to the R&D. You need to have an R&D process for that. You have to have a lot of government financing in most cases for that R&D. Many demonstration projects. If you look around, kind of a lot of the hype, there's a lot of advanced reactor demonstration projects that are currently being built. And you have to demonstrate the technology before you can actually build it at commercial scale. And there's a lot of work that the United States in particular is focusing on into developing that supply chain for HALEU and TRISO fuel. And so when you look at the timescales from like the nuclear kind of readiness perspective of the market, anyone who's using standard fuel, they're pretty much ready to go, right? Because you have the supply chain, you have the regulatory familiarity. It's just about defining the project and getting on with it. Anyone who's using kind of the newer types of reactor physics, chemistries, fuels, those guys are still progressing along kind of the R&D technology readiness level curve. So, we're already looking at our first deployment to be in 2027, so just a few years away. The more advanced reactor technology, people are looking at, in the 2030s, mid 2030s for first deployments.
So it's really interesting. The supply chain for the most advanced new fuels, you were talking about TRISO. So TRISO has the big thing about TRISO is, enhanced safety, and just ease of manipulation. The difficulty with that is it doesn't exist. It doesn't exist in a stock where you can actually purchase it.
It doesn't have a scale.
Exactly. And so what else goes in that supply chain bucket that you said does exist for the remnant, basically, components of the AP1000? So the old legacy reactors, basically, for the benefit of the audience. And so what is it in that basket? Is the fuel? What else is there? Am I missing something else that you need in a power plant that you'd have to purchase that it's special?
Yeah, so I will say one of the things that's actually really interesting when you're at the large scale, everything is bespoke.
Okay.
Every pump, every single seal, it's the cranes that you have to construct everything. There's this, actually, you would love this, your audience would love this. There's this crane called Big Carl is its name, because it's the largest crane in the world, and it's exclusively used for nuclear construction projects. It's so massive. But yeah, so everything is bespoke when you're at that large scale, because everything is huge. It's absolutely enormous. And so, that's great. That's good for them. Lots of jobs, lots of specialty jobs. But when you're at the micro scale with Last Energy, nothing is bespoke. So our supply chain is incredibly robust. At the 20 megawatt scale, our balance of plant is really similar to a comparably sized, biomass plant or waste to energy plant of 20 megawatts. So we have, the energy supply chain, the oil and gas supply chain is our supply chain. So when we need, a pump or a seal or a pressure vessel even, or a turbine, we go to the traditional vendors that you would think of for, the thermal energy supply chain. And so that's actually a really critical design decision from our perspective as well, to rely on to be able to design a product that expands the supply chain. Therefore, we're able to reduce costs, because as opposed to having one-off bespoke components, each one, you can't really control costs when there's only, it's completely designed for you. But I can go call up 50 vendors in many cases for each, and we have for each component in our power plant, and find the competitive bid from a global supply chain that isn't producing one a year, but is producing hundreds or thousands of these components per year. So not only does the supply chain exist for them, there's competition in terms of the pricing, it's also well characterized, and that helps with the regulatory piece as well, right? The regulators don't just look at the nuclear reactor. They look at everything, every aspect of the design. They want to ensure that everything is, incredibly reliable. And so we have, operating histories and data and reliability data from every component in our plant that the more bespoke supply chains just don't. So that's also really, really beneficial when you can go small and utilize existing supply chains.
Understanding that scale here, it's key. If you want to reach scale, you need to have almost off-the-shelf components to be building these.
Mm-hmm.
And then, so your idea right now is to build them in a factory and ship them?
Exactly. Yeah. So, yeah, building them in a factory setting is beneficial. One for, as I kind of said, kind of controlling costs, but even from, again, there's licensing and regulatory benefits as well, right? The inspectors can come and see, the process during construction a lot easier. But yeah, so we build them in a factory, and then we truck each component on the back of a flatbed, deliver it to site. One of the key things as well about our plant's design is in order to really ensure, I mean, I told you earlier, nuclear theoretically can be placed anywhere, right? But it's still, the traditional tech actually does have some limitations because of cooling and because of just site civil work that has to be done. So we've also done some things to minimize those requirements so that we truly can unlock universal siting. So the two that I just mentioned, cooling. So traditional power plants and the majority of the new designs you'll see in the advanced market, pretty much anything that's over, let's call it 50 megawatts electric, is going to require cooling water intake sources to cool their tertiary loop of the power plant. So that means it has to be located near a river, a lake, or the ocean. A larger body of water, the larger you go. So that really geographically limits you. And then the second thing, of course, the larger your plant footprint, the more civil works you're going to have to do, which just limits, where you can physically place these in terms of plots of land. So what we've done to avoid that is, one, we use air cooling, very traditional in the thermal and energy generation space at this size. It does have an efficiency hit on our plants. Obviously, air cooling is not as efficient as water cooling, but it allows us to site next to our customers critically, right? And so that's really important. So if you look at our plant online, you'll see at the top, there's all these little fin fans. So that's the air cooling system. And then the second is the site civils. So one of the things we've done, instead of requiring, really complex civil work, laying a concrete pad, which nuclear concrete is a big cost driver as well, we use steel piling so that we don't have to really deal with concrete really at all. So when you are at that kind of on-site assembly phase, it actually only takes, our estimate is only going to take roughly 3 months for the construction part of our assembly. All the other construction is in manufacturing, and then when it's delivered to site, it only takes about 3 months to assemble.
Okay, so you've designed this optimizing for speed and scale, as opposed to IA's efficiency. That's just not the goal, because the customer already has baseload power that works. That's what they want.
They just want power. And also, I mean, nuclear is already really efficient, right? I mean, it's like the energy density is unreal, right? So yeah, a couple points to efficiency so that we can, better service, our customers. That's great for us.
You know what I'm trying to imagine? I'm trying to imagine what it takes for a company that's developing a new design of a plant, not a reactor, just a plant, right? I'm not even talking about the reactor. What does it take to get approval? So riddle me this one. When is it that do I have to engage with the NRC? Do I have to engage the NRC when I'm designing a reactor? And then therefore it's completely new technology, literally to just get that transformation of energy going. And so that transformation of energy happens with some risks, and the risks needs to be evaluated. Or do I have to go to an NRC also when I'm building a plant and the entire design of the power generating facility is to be audited to understand if it's safe or not, if it's up to the standards or not? How does that work?
Yeah, so you have to engage the regulator to build a nuclear power plant. So the whole plant. So different regulatory bodies have different processes where, companies can engage early and get earlier feedback so that they can ensure that when they're going through the design process, that they actually think about the regulatory requirements in that process, and that actually saves a lot of time. Most companies do that. We've been engaging with the ONR actually since 2021. I want to say was the first year we started meeting with them for just informal pre-engagement discussions, just to get to know the regulator and build their confidence in us, but also to truly understand what their requirements were and ensure that when we were designing our plant, that it would meet those requirements and exceed them, because that is ultimately the goal. But yeah, so you engage early for that feedback. And then, if you want to build a nuclear power plant, you have to get a site license or a construction license. In the US, they call it a construction license. In the UK, they call it a site license. So that is the point where you go through the formal process. So when you have, for us, it'd be when you have the customer and the site, but Sometimes it's the grid. So yeah, when you have the location picked out and you're like, all right, I want to put this project here, you take that project to the regulator. And they're not just going to look at the reactor and the full plant. They're going to look at everything, every potential impact to say, from a safety perspective, a security perspective, and a safeguards perspective to humans and the environment from that plant. And so, yeah, they'll really look at all of it from a technology perspective, but they'll also look at, is this going to be maintained and operated by an institution, by people that are going to be able to operate it in a safe manner through its entire lifetime. So they don't just assess the technology and the project, but they assess the organizations that are developing it and will ultimately own and operate it as well.
Looks like a little bit of scrutinizing there.
I mean, yeah, but it is important, right? You don't just build a nuclear power plant and then say, okay, we don't need to make sure it's safe anymore because the design was safe. No, it as soon as there is a irradiated material on site, it's important to ensure that it's being handled properly throughout its entire lifetime. And that's one of the things that's actually really awesome about the nuclear industry is like the attention to ensuring that, we treat safety and waste handling and just ensuring that we know where everything is and the status of everything. It's actually just really impressive. You look at other energy industries, the old ones, or even the new ones, right? Like there's not the same level of, I guess, I don't know if it's care. I think we have to do it because the way we're regulated, but I would wish that, more energy industries would take better responsibility for the end of life and the full life cycle of their products. The nuclear industry cares about the entire life cycle of its materials, be they nuclear materials or concrete or whatever it is. And so I just think it's really impressive that the industry has gone to such great lengths to ensure safety throughout the entire process.
And interestingly enough, what held back a lot of nuclear developers and developments in the past, maybe if we can crack speed and scale, maybe what keeps this industry sustainably efficient and sustainably just operating sustainably in the future. Because we already have really high standards for what it means to set a power plant in the ground. This is huge. What are you guys excited about? Because you're about to do 2 deployments in the UK.
Yeah, so we just announced one project. So we announce projects when they're like baked. We don't, right? So the project we just announced is in South Wales, and that's going to be for 4 units, so 4 of our 20 megawatt power plants on the same site, serving actually a number of customers, both industrial and data centers.
Okay, so you're selling also heat. You're selling heat to someone, and then you're selling electricity to data centers.
Yeah, and electricity to everybody gets electricity. Yeah, but
Everyone gets it.
Yeah.
What about outside of the UK? Do you have anything planned in the US or outside of the US and outside the UK?
Yeah, so we're also active in a number of other European countries. So we have projects in Romania and Poland that are ongoing. And then in the US, we historically, so when we did our go-to-market kind of analysis of which countries we were going to go in, we were extremely objective. And this is probably my fault coming from the policy perspective. We were extremely objective. And, we didn't say like most founders do, okay, we're American, therefore we're going to build here. This is what we know. We're like, no, truly, our goal is, if our goal is speed and scale with our product design, our goal from the business perspective should be speed and scale as well, right? Where can we actually truly build these in the most efficient manner as well? So we looked at that from the market perspective. We started actually with like a list of like 50 countries, and looked at about 75 factors across all of them. But really it comes down to like those 3 core criteria I outlined earlier: energy prices, the enabling regulatory environment, and then also, of course, favorability or positivity towards nuclear from the population and the government is also critical, right? We can't build in Germany for a reason, for example. And so the US historically, when we were doing that analysis, had failed 2 of those 3 market criteria, right? The high energy prices and the enabling regulatory environment. But as we've been alluding to this whole conversation, those trends are starting to reverse. And I think that's really come on the backs of, one, the recognition of nuclear in the energy transition just broadly, and two, actual, dollars on the table from big players like the hyperscalers that we're seeing. And I think also, with the election that recently happened, there's a lot of emphasis on regulatory reform. And that to us is opening the US market for us to take, another look. When, as I said, historically, it just wasn't necessarily the case. So yeah, with the new demand and the potential for regulatory reform, I think the United States will become a market. But of course, we'll approach it, as we do with everything, extremely objectively. And we'll make sure that we have a project that really sets us up for success here in the US.
And I'm sorry to ask you this question. I don't want to put you in any bad position. You don't have to give me an opinion. But so with this administration change, Trump going in the White House in January, what do you think will change, if anything? Because maybe there was already a big process ongoing the US, if there's one thing that I can see from outside, is like that the US has usually less stepwise changes in things. There's more of a longer term vision than Europe. And you guys might not perceive it like that, but I can assure you that we're way worse off with canceling off and rewriting every single legislation what the macro policy should be. So how do you think about this new administration change, and you from a policy perspective, and how will nuclear be impacted, do you think? What's your general take?
Yeah. So I've worked under the Obama administration and the Trump administration before coming to Last Energy. So I didn't do any work directly with the Biden administration. But even back then, right, from the transition from Obama to Trump, well, at the end of the Obama administration, I think the general mood was that we kind of lost the race. And when it came to the nuclear race, right, Canada had gone through this great reform, and you saw the UK really pushing, and there was kind of like, oh no, like we maybe missed the boat. And so I think that in the next administration, that was obviously still kind of the vibe, and so some efforts were made to focus on nuclear. And it was primarily actually acts of Congress between the Trump and Biden administrations, now both cycles, where Congress has passed, I want to say at least 6, maybe even more. I haven't counted all of them in summary, but a number of bills that are looking at trying to, attract new entrants to have that kind of homegrown U.S. nuclear industry. And some of those has focused, as we talked earlier, on, early R&D for advanced nuclear technology. Some of it has focused on ensuring we have, robust supply chains for, nuclear critical components, including fuel. And some of it has focused on, passing reforms to the licensing process. But I think the big change that I would anticipate under the second Trump administration would be on that third piece, on the regulatory piece. When I was in working under that administration previously, dereg was the hot word in Washington, D.C. It was really about, is this process, is this agency, is this office efficient, and is it actually serving, serving the priorities of the administration, let alone like is it advancing something that's valuable? And if it's not, then let's cut some red tape and let's rethink it. I think that administration, in a necessary way, I think it, a lot of even in the UK, we've seen, this type of thing happen. It's good to take stock. But I think with the red sweep, as we're calling it today, and I think it hasn't been fully, 100% clarified that Republicans will take all 3 branches of government in DC. But not 3 branches of government, because that implies the Supreme Court, the House, Senate, and the presidency. That this will be actually much more impactful because there is not a real resistance to that reform. So yeah, I think on the regulatory piece, we should be able to expect, reforms that would make it more attractive for new entrants to enter this market. But I can't guarantee that. Of course, that's what Last Energy, that would be our perspective, is what would make this a more attractive market for us.
Fully clear. I think it's well needed to kind of like reassess what that process was, because the US did to some extent lose that race. It doesn't mean that it's going to keep losing that race. It actually can get back in game. I mean, you guys are one of the testaments, in my opinion, for the US nuclear industry that the US has in the last decade lagged behind. Because a company of your standing, with what you're building and the kind of like the brilliance with which you've designed the process and a go-to-market strategy, in the end, you haven't chosen your own country to go there. And I'm sure you want nothing but building in the US as soon as possible. I can imagine that. So one thing that I want to try to figure out with you is, how are you looking at the early stage market in the US for founders that want to build small modular reactors? Like, have you seen anything in that realm? What have you touched there? What have you spoken with?
Yeah, one of the things I think is interesting is the role that the national laboratory system can play. And it's a huge advantage the United States has that pretty much no other country really has. And we have 17 national labs that under the Department of Energy. And I think that the assumption used to be that the first customer for an advanced nuclear technology would have to be the government or the Department of Defense. And that is something that we're kind of realizing now. So there's a company called Oklo. Their first project is going to be built at Idaho National Lab. I think Idaho National Lab is actually kind of incubating a number of first deployments at their site. And that's one of those technologies, right, that is, and has those new types of fuel, new types of chemistries. They have to build a demonstration before they can fully commercialize. And to have the National Lab System, the Department of Energy, help facilitate that is actually really beneficial. Within the Department of Defense, even smaller than Last Energy, you see what I think they call them mobile reactors, or I don't know if there might be another very small reactors, right? Call it like 2 megawatts maybe on average. Or less, even in the kilowatt range, that the DoD is looking at for various applications as well. And so they, we've seen, companies like Radiant, if you've heard of them, look at opportunities within the Department of Defense. And so I think that work has been ongoing for the advanced reactors to get those first customers that you couldn't really go to a private sector industrial, pulp and paper manufacturer and say, well, you be my first customer. Can I build a demonstration project for you? Right? That doesn't really work. So that's something that I think the US has done really well, kind of in the past. And I think that will continue to advance the development of these newer technologies that do require those demonstration phases and customers that can take the risk as well if they don't actually pan out.
It's really interesting how I think in the next, this is a question because I have a view on this, but I value yours much more. What does the nuclear industry in the US look like in 10 years? Oh. Is it one big giant, Westinghouse roll up? Or is it a bunch of different IPPs that are building reactors? They're completely new entrances and they almost become, new. Yeah, they're just IPPs. And so you're going to have to start doing much more engagement with utility, transmission line operators, etc. So how does the market look like in your opinion?
Well, ideally we'd move to the market like every other market, right? Where you're actually competing on price and on merit. I think that's one of the things that's kind of been crazy about the nuclear industry because it has been so reliant on government funding for projects, right? That if the big guys are going to win, right? Yeah. Those contracts are the ones who are writing the RFPs, and therefore they're the ones that are going to win them. With all these new entrants, especially with those who are working, like for example, like for Last Energy, everything is private sector, right? We're a private sector business. We sell power to private sector businesses. and we get financing from, private finance.
Waters.
And so government, aside from the regulatory side, just really isn't involved. And that means that we can truly have like real market competition. That's where I see this going, especially for those that have adopted similar business models to us. In the larger scale space, I think that there will be a big consolidation, probably around, the first few to having a project come online, right? Because these will be the ones that are selling to grid operators, and then we still have like a pretty large financing requirement. I do think but I don't think they'll be the Westinghouses of the world. Westinghouse does have a horse in this race. They have a small modular reactor design around 300 megawatts, so grid application. They obviously have a ton of experience and therefore, more power to them. We hope that they succeed in that race. But there's a number around that size that are competitive to Westinghouse. And so I think that we'll see a consolidation in the larger scale market as well, where hopefully they'll also be, though, competing on the factors that we care about, right? Cost and time to delivery, right? If one of these companies, despite their reputation, takes 10 years to build it, they shouldn't be the ones who are relying on for the energy transition.
It's fully clear. I love it. I love that take. Approaching to the end, I kind of want to ask you like a last question on what do you see missing in, there's another point that I was actually discussing with a friend of mine, and it's education. It's like the talent that is needed, all the steps of the value chain. So actually what he was saying, though I was talking to him about, hey, what's missing in the nuclear industry when it comes to talent? He's like, hey, the upstream stuff, designing a reactor, designing a plant, we got everything. We got great engineers. We got tons of papers to draw inspiration from. We just got everything. Like we don't need more. We don't need a reform to get nuclear engineers exist, mechanical engineers exist, civil engineers that figure it out exist. But we might be needing that hyper skilled labor that is powering those plants, but that is managing and operating those plants. By the way, this shouldn't probably be a big concern for smaller scale plants. I can imagine. I mean, just reverting back to you. But where do you see the biggest lag here? Like, where's the shortage? Is there any?
Yeah, well, I do think that there is. I mean, I do usually hate this question because it's all like in nuclear conferences. This is always a topic that folks want to talk about because like they're attended by people who want jobs in the nuclear industry, right? And so you have to talk about work skills development stuff, right? And so my actual opinion on this is like mildly controversial, in that like from I think Last Energy's perspective, right? Our plants are from the construction side. I'd rather have folks who are used to building, offshore drilling platforms constructing my plant than someone who has an expertise in building a nuclear power plant, because the way the nuclear power plants are built today isn't very efficient and takes too long and is just complex, right? I want people who have built hundreds of projects working on my project, right? And I would like to pull that talent from other energy and construction disciplines. That's from that side. In terms of operating, we're also entering a new technology era that is going to change how that works too. The majority of power plants that are in operation today that were built, in the heyday and then this, continuing to the 70s and 80s, they're like analog, right? There are people walking around with flipboards, those big, there's buttons you can like physically push. I mean, it's kind of crazy. They're not modernized in that sense, right? And these new technologies are using, modern instrumentation and controls, that just puts in a different operating paradigm, right? In many cases, you don't even have to be at the facility. There's nothing to do at the facility, right? If you look at our power plant design, there's no operating room, right? There's no like spot, and it's just a power plant. It's operating 24/7. It's on or it's off. And there's really, it's a different operations paradigm. What I do think is, where are the jobs going to grow? In the construction sector, because as you have smaller projects like ours, right? 20 megawatts, we don't have a single project where we're only going to build one, right? At least right now. We're building, as I said, in the Welsh project, four. Majority of the contracts we have in our pipeline are 5 to 10. So it's that construction project expertise that we really want to be bringing in, and we want that to be local, right? We don't want to have a workforce that's traveling all around the globe. We want to be able to transition, these types of folks in the countries we're working in to work on our projects.
And most of the work is done by the design. The design needs to be feasible for any medium skill or just an average workforce. Anything that's you just employed to build solar power plant, and you employ an offshore. You were saying offshore oil rigging platform. Yeah, no, that makes sense.
Yeah. So yes, there are some specialty things you have to think about, right, in terms of like ensuring that your welds are up to spec and code, but you have to do the same thing in other industries. It's just that there are slightly different codes for nuclear.
Gotcha. Well, Michelle, this has been an amazing kind of like deep dive in what's the old, what's the new, what's the future of nuclear. I think it's incredible that you guys have been, with a few others, are taking the kind of the front and center post of this new through potential revolution in how we generate energy, above all for industrial use, which people don't realize most often is just most of the carbon emissions that we do. So this is what we want to see. I'd love to see more and more founders building stuff that it's not only hard to build, it's just hard to just conceive and then make that problem, granular and small, put it into a factory, modularize it, and ship it to another country. I think the playbook that you guys have been following is just exemplary. And I love what you and Brett have been doing since the beginning. And I kind of want to revert this question that I asked to every single founder, builder, investor that comes on this podcast. And that is, what is a one big, piece of advice that you wish you had before, for someone that's building hard things, not for someone that's building something that it's, that it works. That it somehow, if I crack, code or whatever, it's just going to work. Something that it's just hard by design. What's an advice for a founder that's just embarking on this challenge?
Yeah, I think, to put it in 2 words, it'd be like, think bigger, right? I think the way that we have been able to really manifest that is, this is a legacy industry. There's legacy regulations, there's legacy ways to do things. And you can find yourself just saying, okay, well, how was it done? Let me slightly modify that to like work with my idea and my tech. And then like, I'm going to try to chart the typical path. Like, think bigger than that. Like, is this current system that you're entering, is it the most efficient? Like, can you truly disrupt it? And like, be bold and inspire people along the way. I think one of the things I find just so interesting is, like the most conservative folks in our industry are the nuclear regulators. And we're coming to them with a completely new approach for thinking about licensing much simpler and safer technology because it has that merit, right? And really truly putting in the time to work with them to believe in and like understand and be just totally bought in. Like it's worth putting in the time to let others think bigger too. And so I think that it's just important to like work with your most critical stakeholders, and that's how you're actually going to affect the change. You can't go in like a bull in the china shop and say, here's how I'm going to do it and all this stuff. You have to like come up with strategies and plans that truly make sense and help people kind of get to that place with you. And then you can actually enact those bold plans. It's something along those lines, I think.
Something along those lines. So if I have to sum it up, it's like, think bigger, and then also don't force your way. Find a way that makes sense for the industry that you're playing into.
Inspire them to go bigger too. Yeah.
I love it. I mean, Vishal, I thank you so much for your time. I know you're extremely busy building power plants overseas, just as one. But I hope we can do a part two, soon enough. We'll obviously stay in contact. And yeah, I mean, again, thanks for being BitBuilders. We'll love having you.
Wonderful. Thank you so much. It was awesome to be on.